Good evening, all of you. This is our crash course for GATE Aerospace for 2023. This is our day 1. In this crash course, some new students are there. They will study all the content, 100% coverage, whatever topics are there, whatever we have gone through in a regular batch students class, and regular batch students will revise their syllabus in this crash course. Now in this crash course, many regular batch students are absent. They are not joining because many of them, they have missed so many regular batches, regular courses, regular classrooms. So they are still covering them using videos. So I have advised them, if any student is in this condition that still 20% or more than 20% syllabus is pending, then first go through regular batch class recorded videos, cover that syllabus, because this crash course is either for totally new students or for those students who have done regular batch all the classes in detail and their notes are ready and now they are willing to revise the session quickly. I hope clear. And this video I will upload publicly on YouTube for advertisement purpose, so that other students can know how are we going to cover entire syllabus. Okay, so now see what is the plan here. Whatever core subjects we have, first I will talk about them. I will classify GATE Aerospace 2023 syllabus. Now you see, first I will divide this as core, and then we have our general ability. In general ability, and of course the third portion we have engineering mathematics, but I was about to take this under core anyway. In general ability, you know, total 15 mark questions are there, and this 15 mark questions will be covered from verbal ability, numerical ability, and from last few years you can see there are some standard reasoning questions are there. Guys, Revant is claiming he is not able to see the screen. Others, do you have the same problem, or you guys are able to see the screen? Yeah, actually there is some screen problem from his side itself. Okay, so this verbal ability portion is actually dangerous if you are covering this in crash course. Okay, again, in crash course, verbal ability, numerical ability, and some important reasoning topics are there, like image based questions, and in image also some basic aptitude mixed questions are coming, if you see from last 2 years. Okay, so how to cover this portion, this particular thing I will discuss separately. Now my main focus is actually covering verbal ability in these 3 months. It's difficult. Why I am saying difficult? Because if you complete anything in verbal ability, what is that? So some tenses, some grammar portion and those things. But see, believe me, if you are learning these things for the very first time, then it is not possible to attempt GATE question. Okay, I am not saying for very intelligent students. Very intelligent students can do anything in their life. They can even prepare for GATE exam in single day. Okay, and lot of YouTube videos are also there. So like they claim that they have covered everything in this much time, in this much time, in this much time. Okay, so anyway, now next point is, so I am saying totally boycott verbal ability if you are if you are not regular batch student, if you are crash course batch student. It is not from my side, it is actually from your side, because lack of time. So we have to choose our portion wisely. Then we'll go for numerical ability. Okay, numerical ability, if you practice, roughly you can say 30 to 35 small units are there, chapter wise units. Why I am saying 30 to 35? Because in this 30 I am saying a pet unit. For example, easy chapters, for example work, time, distance, average, percentage, these kind of chapters. And what I am adding extra in 35, here you have PNC, permutation combination, probability, statistics. So actually these 35 chapters, like the tougher one, they will consume your time. If I say straightforward, permutation combination and probability itself will consume more than 10 days. If you are sitting 3 to 4 hours every day, then you need roughly 10 days plus practice to do very good command on permutation combination and probability and statistics. Anyway, statistics is very easy subject, chapter portion. So but loaded, weightage is not enough. So you can ignore this portion. Now where can you focus? You can focus on those pet chapters where you can get your grip in less time. In less time means in these 3 months only you have to plan everything. Okay, I'm saying 3 months, but reality is we have complete October month, November month completely, and December month completely. So I will finish all the portions in these 3 months, including test series. So everyone please unmute, and whatever test series we are going to discuss every night after the class, like for example tonight I will discuss, okay, just hold for this, I will discuss about test series. First let me explain about the syllabus. I hope I'm going good in general ability. So in general ability you have 15 marks. Crash course students, they can achieve 15 out of 15. It is a very tough, very tough task. I am not creating any kind of fear and or phobia. I am talking practically so that you can invest your time in right things so that you can get more marks. Your intention is not to achieve 15 out of 15 in general ability. Your intention and attention should be to select to go into IIT IISc somehow means in prakaren. Okay, somehow you have to go there. So there are so many other portions where you can hit at your personal level. Again I am saying from my side I am going to cover 100% syllabus, but I am saying that when you have to filter the subject, that time your ego should not come in front of you that okay, how can I skip this portion, how can I skip this portion. Okay, I am aerospace engineer, I am this, I am that. No, I will complete 100% syllabus. So there will be some time when you have to compromise with some chapters. Now in numerical ability, whatever portions are very important for us, what you should not leave at all at any cost, those portions I will guide you during the live courses that okay, this much, day by day you have to cover somehow. Okay, you can compromise some portions in core, but those chapters of numerical ability you cannot compromise. For example, work and time is very important portion. Okay, and toughness level you can't even imagine. From 0 toughness level to cat toughness level, these kind of questions they can ask, especially in work and time. Now we'll discuss about engineering math. I hope I'm clear how to cover GATE general ability. In general ability, strictly boycott your verbal ability because of less time. Jump to numerical ability part. When I'll be taking classes, that time I'll be guiding you what are the chapters you should not miss and what are the chapter you can easily ignore. Now come to engineering mathematics. Here we have to cover 100% syllabus, whatever is mentioned in our GATE notice. Okay, everything we are going to cover. So no problem about engineering mathematics. Now come to core. In core, we have actually if you study in your university, then courses will be organized very differently. But if you will see the GATE pattern, lot of chapters they have merged and lot of chapters they have skipped. For example, there is no section which covers aircraft design. There is no unit in our GATE syllabus where we have to cover aircraft design. Okay, in some universities and some institute, vibration is not taken properly. Sometimes 0, sometimes only 1D vibration they take. But in GATE syllabus, we have very good amount of vibration content. Okay, so I hope you're getting how I'm taking you. Next part, in core subject, I am going to start with aircraft propulsion as I do always. My first intention is to teach aircraft propulsion. Why? Because it is tough and lengthy. Then I will start aircraft structure. Again, why? Because it is tough and lengthy. See, when I say it is tough, don't take in negative way that it is tough. It is tough means when you compare as compared to other subjects like with flight mechanics and aerodynamics and space dynamics and rocket, then you find that it is lengthy and tough. Actually, see, as an engineer, nothing is tough for us. But of course, as an engineer, we try to finish everything before 2 days of our semester exams. So anyway, like still you guys are doing the same. Whoever is attending crash course program, this is day 1. You guys are also taking GATE exam is also in almost same thing. Before 3 months or 4 months, you are targeting GATE exam. Anyway, I will not spread any negativity. We have to see only positive aspects of crash course. Again, I am saying, especially I don't believe in crash course because you guys are paying me. I am taking the classes for crash course. It is purely business thing. Okay, but 100% syllabus I will cover in detail. Let's go ahead. That's why number of hours I have increased for the crash course. So I will take propulsion first, then structure first. In your university level, I am changing the page. In your university level, in different universities, aircraft propulsion syllabus is divided in different segments. For example, maybe in some universities you may have propulsion 1, propulsion 2. Maybe in some universities you may have heat transfer separate subject, propulsion 1, propulsion 2 separate subject. Maybe thermodynamics separate subject. Maybe in some university thermodynamics is not at all as a separate portion, it is included in somewhere in propulsion. In some universities they also teach IC engines, they don't teach. Okay, my point is GATE syllabus is different, and whatever I'll be taking in crash course, that will be exactly focused as per GATE syllabus. So I also teach in same way for regular batch students also. So my first unit will be thermodynamics. Immediately after that I will be taking gas dynamics. Now point is, gas dynamic portion, why do I cover under aircraft propulsion? Because when you will be going through jet propulsion unit, under jet propulsion unit you will be encountering some words like normal shock wave, oblique shock wave, expansion fan. These words you will go through when I'll be teaching you nozzle problems, intake exit problems, these type of problems. There we face these type of words. So student will be uncomfortable if suddenly during jet propulsion normal shock wave or these kind of waves will appear. That's why I take gas dynamics just after thermodynamics, and I used to include gas dynamic as a part of aircraft propulsion. This is my way. Okay, it is not given, this is not the way of GATE syllabus. In GATE syllabus, gas dynamic portion lies under aerodynamic portion. So my test series of gas dynamics is also covered under aircraft propulsion unit. I hope it's clear from my side. Now next thing, so when I'll be teaching you thermodynamics and then gas dynamics and then only jet propulsion. So in thermodynamics, what are the basic points we have to cover with very good logic? You see, you may have heard about there is something called continuum, there is something called microscopic views. Like these are small things. You may have heard about point function, path function, intensive, extensive quantities, and we will be seeing them based on numericals, because in regular batch we used to discuss everything in more detail, but here we will try to go through technically using some examples. Then still, because we are starting still 3 months ago, so we have you can say we have time, we can manage our speed and hours, and we can go where, and one more thing, wherever is required I will go into sufficient detail, because my intention is not to just cover the syllabus. At the same time, if possible, as max as possible, I will try to go into detail. But if there is lack of time, I will clearly say that this much portion still we can go in detail, but because of lack of time, only you go through formula and this part, and that's all. You can attend the GATE question. No need to go into detail because of lack of time. Okay, and I will also suggest you in that case, if you are interested and if you have paid the amount, then you can access this particular topic in regular batch video course. I hope clear. Okay, we have to see temperature, pressure, volume, density, these small topics. We have to see absolute pressure, atmospheric pressure, gauge pressure, vacuum pressure, different types of pressure, explanation of pressure at molecular level, static pressure, dynamic pressure, all these, hydrostatic pressure, right? So because you will understand the basics, then only you can go for jet propulsion complete unit. And intention of learning thermodynamics so that you can be very good in propulsion. Because if I directly start jet propulsion without the intro of thermodynamics, then you will suddenly get stuck, sir, what is enthalpy? Okay, so after that we'll be going through types of equilibrium. So in types of equilibrium we have 4 types, right? Thermal equilibrium, chemical equilibrium, mechanical equilibrium, phase equilibrium, and combined all of this you will be having thermodynamic equilibrium. We'll go through state, process and cycle. We'll go through different types of energies like macroscopic, microscopic, internal energy, stored energy, enthalpy. These things we are going to cover. Okay, and now you see, if you focus on GATE syllabus, they have added heat transfer as well. So heat transfer unit we are going to cover here itself. Okay, before going through heat transfer unit, you should have complete idea about ideal gas and ideal gas law. Once you are comfortable with ideal gas law, then heat transfer becomes more easy, because whatever heat transfer we are going to discuss, that heat transfer is not about transfer of heat through the metal. Transfer of heat we are going to discuss especially with the help of gases. Okay, and of course there is one question they have asked, heat transfer through the metal. Actually this is the unit what we used to discuss under IC engines, but we are not going to discuss IC engines in detail. Okay, and important part is thermochemistry, that I'll be taking in the last of complete jet propulsion. When aircraft propulsion will get over, that time I'll be taking thermochemistry in detail. I hope going well. Now you see, after completing heat transfer, we will also see the unit of work transfer. After that, immediately we'll jump to zeroth law, first law, second law. Okay, in second law we are not going to discuss numericals because second law numericals are not the point in case of GATE aerospace. In case of first law, we will be discussing, of course, steady flow and unsteady flow in detail. That's all. Whoever is watching this video in video course, don't even think that after second law you should go for any type of power cycle or something. Those things are not for aerospace. Those are the points. And one more thing, we will also discuss entropy in detail. Yeah, so don't discuss those kind of like corollaries of first law, second law, energy, exergy, irreversibility. Those things are actually covered by some teachers in GATE aerospace, and they are worst criminals whoever is teaching you these points under GATE aerospace syllabus. Okay, and you can strictly ask them to stop teaching this, because I have gone through some channels for GATE aerospace and they are teaching these things under GATE aerospace thermodynamics, because you know what is the main point, because they know that point, that's why they are teaching that. Our GATE syllabus is limited. We are aerospace engineers. Don't be confused, you are not mechanical engineer. Anyway, properties of pure substance also I have seen people are teaching properties of pure substance. Okay, and how are they saying in the class? If you go through their YouTube channels, they are saying because it is ideal gas property, that's why we have to go through pure substance property. Though I hope I'm clear. Let's start with our first important point, very important point, the concept of continuum. So your first point is concept of continuum. Let's understand. Okay, so we are starting now our journey, concept of continuum. Okay, and meanwhile, whenever I'll be starting new subjects, I'll be giving you detailed intro of the subject, and that particular class I'll be uploading on YouTube for advertisement purpose. Okay, so concept of continuum, let's understand. Regular batch students already they have gone through, they will be having some basic idea. So I'll be teaching this using new words. Guys, you see solid, you see liquid. When you are drinking liquids, for example tea, coffee, when you are taking tea, coffee, water, then it's not like one particle is going in your mouth and remaining particles are going back to the glass. Or it's not like you are trying to suck the water, or you're trying to spill the water by shaking the water. Then some part is going this side and remaining part is going into the atmosphere for always, right? Actually they are connected by each other with some kind of forces at molecular level. Okay, of course there is a defined name for that. You may have heard van der Waals forces. We are not going to that detail of chemistry. My point is, to define continuum you should bother only about two words. One is continuous and one is homogeneous. So see, if matter distribution is continuous and homogeneous, then only that particular medium you will say as continuum. Now point is, in case of solids, continuous distribution and homogeneous distribution, both are possible. In case of liquid, continuous distribution, homogeneous distribution, both are possible. But in case of gases, actually what happens, particles are free to move in the atmosphere. That's why particles used to go into the atmosphere. Okay, and in atmosphere several other gases are present. I mean to say, after one particle you may not have the same particle just next to that, you may have some other particle next to that. It means what? There is no point of homogeneity, so there is no concept of continuum. Now point is, we are going to consider our gases, whatever gases we are going to discuss in our numericals. For example, if I am taking a numerical that in atmosphere pressure is this much, temperature is this much, so these datas are actually for ideal condition. Okay, in that ideal condition we consider our air, whatever air is going into the aircraft engine. You may be knowing that our aircraft engines, they are air breathing engine. To work well they need air supply. Why? Because they have oxygen content. Now point is, if oxygen content is not homogeneous into the air, then sometimes this engine will do very good performance, and sometimes this engine will not do perfect performance. You can judge this by putting some special sensors inside the engine. You may be knowing that Airbus and some other companies are doing these kind of research now, so you have very good opportunity of job. Okay, a very new batch, it is not very new, a very new branch of engineering that is known as data science is actually boosting. So as an aerospace engineer, you can work as a data analyst in these Airbus or Boeing companies, because they are putting sensors in their engines and other parts, and they are collecting hell amount of millions and billions of data, and your work is to arrange that data and look for any pattern. This is what the role of data scientist, and advise the company for the better benefits. Okay, so my point is, your air, I mean our air, whatever air is present in the atmosphere, that air is continuous, or that air is homogeneous? No. Point is, our air is, in reality it is not continuous, in reality it is not homogeneous. But for our ideal case, for our UG syllabus, we have to consider that whatever gases we are going to burn in the combustion chamber of aircraft engine, those gases are actually continuum. Means the gaseous medium what we are going to discuss as exhaust gases, they are actually continuum. We are going to consider them as continuous medium and homogeneous medium. Some students may have trouble to understand the difference of continuous and homogeneous. Let's understand what is the difference. Guys, see, if I am putting suppose this is salt, then I am putting this is sugar, then I am putting this is any other some masala or something, then I am putting suppose I am putting any water. So if I go through this, continuity is there. Continuity means different types of food, different types of things are placed, but are they homogeneous? Do you have salt everywhere? No. It means this is the example of continuous. Now let's understand the meaning of homogeneous. Suppose I have a bag. In this bag, in this zone I have HCl molecule. Okay, and in this zone I have HCl molecule, in this zone I have HCl molecule. Imagine this total volume is 100 ml. Okay, and this 25 ml, 25 ml, like this, I am putting HCl molecule. Okay, so now point is, inside this bag, do we have homogeneity? Yes. Why homogeneity? Because all the molecules are same. Same means similar. They all are HCl molecules. So this is homogeneous. But of course, no doubt this is homogeneous. But is it regular? I mean, is the variation is sorry. But is it continuous? It is not continuous. We have gap here. So there is a big point, gap. So the word gap is very technical word. This word gap is going to define your medium is continuous or not. So see here, your medium itself will be having some dimension. For example, I am drawing a pipe. This is the pipe I have taken from aircraft engine, and in this pipe, or you can say any duct, I will allow flow to go. Now in the flow, if you look at microscopic level, then molecules are present. Okay, and there is a word, you know, there is something called mean free path. In the molecules itself, there is a word, in molecular world, you take this out. Suppose this is a bag and these molecules are placed here, these molecules are placed here. So actually what happens in reality, they used to hit each other. They used to hit each other. Then you will be having continuously collision. So on average, how much distance is being covered? How much distance is being covered for every collision? It means what? Example, one molecule is coming here, hitting other molecule is coming here, hitting other molecule, collisions, lot of collisions are happening. But one thing is sure, all molecules will not collide at equal distance, right? Maybe one collision is happening between those molecules who are at, just an example, 2 kilometer. One molecule, two molecules, they are colliding, they have a distance just 1 centimeter. Other two molecules, they are colliding, they have distance some 10 kilometers. Don't go on data, just go on feelings. I hope you understand. So you can see the distances. These distances are actually distances for the collision purpose, right? So whenever collision happens, those molecules have to cover some distance to collide each other. So if you find out average of those distances, that we say as mean free path. Okay, so mean free path should be less than the lesser dimension of the medium of the device. Okay, for example, if I have any pipe, in this pipe I am saying it is hollow pipe. Okay, so in this hollow pipe you will be having some thickness, right? So whatever this thickness is, so whenever you are finding out mean free path length of successive collisions, then this data should be lesser than the smallest dimension of the pipe. In this pipe, how many dimensions are possible? I can see there are 3 dimensions possible. One dimension is thickness of the pipe, which is nothing but this much thickness of the pipe. One dimension is radius of the pipe. One dimension is length of the pipe, right? So your mean free path, if your mean free path is lesser than the least lesser dimension, which is nothing but thickness of the pipe, then only we can discuss concept of continuum. Okay, I hope it's clear. Concept of continuum means always go through 2 words. One is the medium should be continuous. Continuous means you should not have gap or you should not have void. So the point is gap here. How much gap you are looking for? Mean free path should be smaller than the minimum dimension of the system. Then you say we don't have gap. Then, because you have to assume that in reality these things will not work. We have to assume that. Then we have homogeneous. Homogeneous without any microscopic hole. Without any microscopic hole. That is only gap I am talking. Okay. So if these 2 things are being followed, then we say continuum. I hope continuum lecture you have understood in detail, because continuous is important to discuss, because in continuum, based on continuum, they can ask you a small question in your MS or PhD interviews. So whatever topics are important for MS or PhD interviews, those topics I will explain in detail. And regular batch students, you guys don't worry, because I am using new words and new examples to explain the same topic, so that you can enjoy the topic in different way. You will be having more exposure to the topic. Let's go ahead. Continuum part over. So whatever I will teach you now, those topics I will update you in WhatsApp group. After WhatsApp group, you will go through the test series. Same topics you will work out through assignments. If you don't have time, then directly go to the test series, and there itself you try to solve the questions, because there are 400 test series and crash course batch students are actually late, right? So if you have time to practice assignment, okay, very good. If you don't have time, test series is very important. Suppose today we have class. Today is 5th October 2022, our day 1 crash course class. After class I will update you topics, like what are the topics we have covered. Anyway, you are sitting in the class, so you are knowing well what are the topics we are covering. Based on those topics, you will go to the test series, right? And you go to the topic wise folder, and you will take those topics, you will solve them, and you will submit them. And next day at 10:30 p.m. we are going to discuss every single question of all those test series, whatever we are solving tomorrow. Okay, so tomorrow 10:30 you guys will come for the test series purpose. Whoever from the regular batch wants to attend this batch, if you think that it is worth to attend crash course also, you guys come and attend the crash course. Okay, if you think that no, your previous notes are sufficient to revision purpose, no need to come and no need to waste your time. Okay, directly revise your notes, and you focus on those portions where you are weak. Okay, and regular batch students will discuss your doubts directly to me. Okay, call me and discuss your doubts. Let's go on the next topic. Next topic is about macro and microscopic properties. So what is macroscopic? Macroscopic means everything whatever you see in your physical life, whatever you can see with your naked eyes, not at molecular level. At our human vision, whatever you are seeing, they all are macroscopic life. So what is macroscopic approach in thermodynamics? Because we are learning thermodynamics. So macroscopic approach in thermodynamics is to discuss about those types of properties what we used to measure with our naked eyes. For example, we used to discuss temperature. We can touch something, we can feel temperature. We can feel pressure, we can feel volume, we can feel density, right? So these topics we discuss at macro, macro, at macro level. So all the energies associated with these topics, with these I will go into detail, don't worry. All the energies related to these topics we call as macroscopic energies. Exactly same thing, all types of temperature, pressure, volume, density we will discuss at microscopic level also, and there also energies will be related, but those energies, of course, there also you will be having kinetic energy, here also you will be having kinetic energy, there also potential energy, here also potential energy, but at microscopic level whatever energies we have, their sources will be something else. For example, kinetic energy at microscopic level, the major source is temperature, okay, but kinetic energy at the microscopic level, temperature is not the source of macroscopic kinetic energy. You may be knowing that 2 by 3 kT we used to give as the equation for the microscopic kinetic energy, but half mv square or half I omega square kinetic energy we used to discuss at macroscopic level, right? So there is two different approach to understand thermodynamics. One is your macro, macroscopic approach, one is microscopic approach. Let's discuss first about the microscopic approach. In this you can discuss first point. Actually this approach, when you will do R&D in any company, I mean research and development work in any company, or if you are doing your MS PhD or any other research program under any professor in any university, that time your work will be based on the experiments. So if your experiment behavior is based on molecules, then it means you are doing microscopic analysis, okay? So it is based on which behavior? Behavior of molecules of the system. Which system? Actually exactly system I'll explain later. So molecules of the system. Your microscopic approach means behavior of your experiment or behavior of thermodynamics quantity is actually based on molecules of the system, okay? You can just note down this. Now second point, actually you cannot sense microscopic properties. Can you sense microscopic velocity? No. For example, right now you all are sitting and enjoying the class. Air molecules, if the bulk air is coming and hitting, definitely you will sense, but a single air is coming and hitting your face, your eye, it is going inside your nose, but are you able to sense? No, we are not able to sense, right? It is not disturbing us, so cannot be sensed. This is your second point. Now go to third point. Actually see here, your data, whatever data you are going to collect as a research scientist, the data will be based on every single molecule. So every single molecule, actually meeting got over, you guys are joining again, so just waiting for some more students to join again. Okay, so I was saying that every single molecule will behave differently. So you are going to judge nature of every molecule. According to that, whatever properties are being changed, we are going to make a list, but of course data will be huge, so you need computer based softwares or programs who can help you to manage all these heavy datas. After that you are going to make sure that how the property is changing for a particular molecule. It means what? Molecular. So of course if so many molecules, so many variations, so many variables will be there. So this is actually, you can say, a very big drawback of microscopic. I should not say drawback, because many people are doing research on a particular topic. So actually lot of variables used to be used in microscopic level to define any system, to describe any system. You need that. Okay, now fourth point. In your fourth point we have, of course, when you have a single molecule and they all are behaving in their own way, they all will be giving you one equation, two equation, three equation, four equation. Maybe some molecules are not behaving in the same pattern of the first molecule, right? So actually behaviors, according to behaviors you have variations, according to variations you have equations. So of course so many statistical equations you will be having, so many. So large number of equations are there. That is also drawback. These things you have to explain in interview. Whenever your professor, when you will be joining MS PhD programs, they'll be asking you these kind of problems, related problems. Okay, so now you see, whenever we discuss our thermodynamics at microscopic level, good evening all of you, at microscopic level, then that time we call this as statistics, we know that, right? So statistical thermodynamics. And so actually what happens, students used to think that teachers should teach them at microscopic level. But guys, we are engineers, we are not scientists. Our job is not to analyze molecular behavior. Our job is to use those results, whatever given to us, and to use them in such a way that we can fly our aircraft, we can design our aircraft, we can design a spacecraft. You are not doing BSc or MSc in thermodynamics, because it happens most of the time students are expecting everything to go into detail at molecular level, but they will forget that actually they are not enrolled in BSc MSc course. You are not doing pure science, you are doing engineering. Engineering is application of the science, right? It means what? We have to focus at macroscopic level. Okay, now point is, whatever happens at microscopic level, this will affect your system. It means what? At microscopic level, molecules will hit the system. So because of that hit, your system will show some behavior. Means what? Your system will go hot. So we will discuss how much temperature is there. Our system will get hit by every molecule. So we will discuss how much pressure is there in the system. I hope you are understanding. Lot of molecules will be gathered together. So we are going to discuss how much density is present in the system. Means you can see which behavior we are talking. Macroscopic behavior we are talking as a aerospace aeronautical engineers, right? Now second point. Once you got your macroscopic properties of the system, how many are they? Very less, very few properties are there. You have pressure, you have volume, you have density, you have temperature, and these are the basic fundamental properties. Based on that, when you combine them, you'll be getting new properties. For example, enthalpy. For example, different types of energies. Means what? Because you have less variables, so of course number of equations will be very, very less. That's why finishing MTech in 2 years is very easy task. But finishing MS, because MS is research based programs, finishing MS in 2 years, it's very rare. There is a power cut, so I'm arranging power now. Just be online. I'm texting you guys in group. I'm arranging power now. I forgot to connect through Wi-Fi actually. Sorry, through UPS.